everyone. Thanks for joining us. My name is Juliana. I'm the owner of the Evolution Store, and I'm joined today by our newest employee, Robbie.
Hi, nice to meet you.
So this is actually Robbie's first day, and he's brave enough to join us on here and talk to us a little bit about a very special fossil that I wanted to talk to you guys about today. It's one of the more unusual fossils that we have in the store. It's not something that you would necessarily recognize when you first saw it. It's not a tooth, it's not a claw, it's not a bone, it's something else. So I'm going to switch it over to Robbie, and I'm going to ask him some questions, and hopefully you guys will be as interested as I was when we talked about it. Switch this around. Okay, Robbie, so first of all, you have a background in fossils and related things, right?
Yes, I studied paleontology. I studied at Manhattan College here in New York, and I also am going to be studying at the Institute for Field Research at the La Brea Tar Pits next summer.
Awesome! Wow, so those are some really fancy credentials. I have none of those, so I'm a liberal arts major, so this is great. All right, so today I wanted to talk to everyone about. Can you describe what this is, Robbie, that I'm looking at right here?
So these are what we call coprolites, and coprolites can be any fossilized dung or feces. These come from a dinosaur. We can tell that these come from a dinosaur because they were found in Jurassic period strata in Utah, and at that time there really wasn't anything big enough to be producing these other than a dinosaur. That's 165 million years ago. This is before T-Rex and Velociraptor and some of those popular ones, but this is the time of like Apatosaurus and Camarasaurus and Brachiosaurus, the really long-necked sauropods. That's probably what was producing these, but because dung is, dung, it can come in many shapes and forms. You can get it from really any kind of large dinosaur. So that's carnivores, herbivores. The way to, I know some frequently asked questions about this fossil is which dinosaur did it come from? And to be honest, you just have to look, and if you see bones, obviously that's going to be a meat-eater. However, if you see what we call gastroliths, which are these small rocks that a lot of these dinosaurs used to break down the plant material, they would swallow these rocks, and it would, move around in their stomach, and it could break down the really hard plant material that they were trying to, break down and get nutrients out of. And at that time, this is before flowering plants, so it's only going to be pines, like a Christmas tree or conifers, pine trees, really hard bristly leaves and ferns like that.
So dinosaurs back then that ate these like hardier plants, they would swallow little rocks to help them digest them because just chewing them wasn't enough?
Yes, so a lot of animals actually do that today. For example, some birds do that, reptiles do that. Well, they'll swallow rocks they have in their stomach so that, and when their stomach moves, it'll crush up almost like teeth in your stomach.
That's fascinating.
Pass those, and a lot of times you would find that in the plants.
So how do people know that this is a fossil and not just a rock? Because when you see it from this angle, I mean, this side has been polished, right? So you can see the sort of really interesting and unique colors and shapes and stuff. But when you see it from this side, just lying there, like how do people recognize that these are fossils and not just random rocks?
So obviously a lot of these are cross sections of a bigger specimen, but it would definitely take a trained eye. If you look, obviously that side, the polished side is the inside. You're not going to see that just walking around. But on that side, you'd be able, a paleontologist could walk by and say, "Oh, this is definitely dung and not just a rock." A better example of that would, I think, be one of these dinosaur bones. So if you look at these dinosaur bones, these are just chunks of dinosaur bone. If you look really closely here, that's the inside, and you can kind of see those tiny little vesicles. That's where the blood vessels would be going in the marrow and stuff like that, which is kind of rough. And then sometimes, I'm not sure if I see any here. This one might have one. You'd find the outside, which is a lot smoother, like a bone would be.
Mm-hmm.
So obviously, it's hard. It's not easy. It takes a long time to kind of figure out. And when paleontologists are walking around in the field, they'll walk around and they'll see something like this that just looks like a rock, and then you pick it up and you look closer at it, and if given enough, I like when I try to identify. I think the the one for me that like really stands out to me would be this stuff. See, like these little tiny vesicles.
Yeah.
If I see
Well,
that,
it's like a cellular structure
yeah.
it's unusual.
A lot of the time, I'll see something that's like smooth, like that. This actually looks like it kind of broke off and chipped, which happens all the time. In fact, most of the bones that you're going to find when you're walking around in the field is you're going to find what we call chunkosaurus, which are chunks of bone like
Unidentified dinosaur bone.
Unidentified dinosaur bone, and you can tell each bone is different. So dinosaur bone looks like dinosaur bone. A lot of the time, what we'd find would be like turtle shells, which are cool. But like if we were looking for dinosaurs, obviously, I would find all these turtle shells and be like, oh, I can't do anything with this. But you find shells, crocodile bone, and osteoderms, like the plates on the back of a crocodile. We find a lot of those, and we say, oh, this is what this is. I can tell just by looking at it, but it's not a dinosaur. When I would find something like this doesn't necessarily mean that it's going to come from an air, there's more underneath it. It could have fallen off a cliff and rolled down a cliff.
Right.
About 65 million years ago, these things were buried.
Sure.
And then they were eroded up until, 1,000 to maybe even more recently. And they could have rolled down a cliff. They may not be where the rest of the skeleton is, even if there is a rest of a skeleton that's preserved.
Okay. Cool.
But sometimes there is underneath. You can take it up.
That's awesome. So can you just briefly, just looking at the dinosaur dung again, it's just so colorful, which I find like really interesting. And a lot of the fossils that we have are really quite colorful. Some of them are brown, and that's kind of standard, but then some of them are really colorful. Do you know why some of them get these like beautiful reddish, orange, yellow colors?
So I asked that exact same question to some of my professors that I work with, and they would always say to me, it's all Kevin physics.
Okay.
Which I guess doesn't really sound like that satisfying an answer, but if you think about it, it is. It's these. I mean, these were 165 million years old, so they went through so many different changes. Obviously, they were probably brown. This is dung. They were probably looked like dung at one point. And then they went through so many changes, so many geological changes over 165 million years that could have altered their colors. Or for example, like maybe reds, and I'm just spitballing here, but maybe reds were an oxidization of like iron.
Sure, that would make sense, yeah. So it depends on the mineral composition of the fossil, because at the end of the day, a fossil, if I'm explaining it correctly, is a piece of organic matter that has over time all the cells have been replaced with minerals. Is that an accurate way of describing it?
Yes, these are essentially rocks.
Yes.
All fossils are rocks, and fossils can only be found in sedimentary rock.
Okay.
Because sedimentary rock is just hardened sediments. For example, sandstone, mudstone, like something like that. Igneous or metamorphic rock is created when there's certain, lava or magma, something scorching it, or a lot of pressure. It's not necessarily the same rock that it once was, and that would destroy a fossil, those changes.
Yeah. Oh, that's so fascinating. Well, this was great. How was that for our first day?
It's awesome.
So yeah, we're really pleased to have you on the team. Thank you for joining us, and thanks for jumping in and doing this just sort of randomly last minute. So if you guys would like to come and learn more about fossils, please check out the store. Definitely follow us on social media, and we're going to be running a special on this dinosaur dung this week. For the next week, you can have free shipping on this with USPS domestic, so we'll be updating our website with that information, and hope that you check out a piece. All right, see you soon. Thanks for joining us.
Thanks.
Bye.
Bye.